Hey everybody, I'm Shashank at Modular. Welcome to the Modular Community Livestream. I believe this is our fifth one. So welcome. Thank you for joining us. We'll take a couple of minutes as folks join in. This is our recap edition, ModCon recap edition. For those of you who are familiar with our journey and have been following us along, we had our conference, our first big conference last week. It was called ModCon, and we had a whole bunch of announcements. This live stream will be focused on all the announcements, and we have some cool demos of products that we announced. We'll go through all of those. So welcome, come on in. If you're joining us from different parts of the world, let us know where you're joining from. I'm currently here in India. I know some of our folks today are on various different time zones. Let's start with a quick round of introductions as you join in, and you introduce yourself on the chat. I'll start. I'm Shashank. I'm a developer advocate at Modular. And who wants to go next? Maybe Jack?
Yeah. Hey, I'm Jack. I'm a developer advocate as well.
Awesome. Dan?
Hi, I'm Dan. I'm a framework engineer at Modular.
Awesome. I'm going by the sequence of tiles I see on my screen. Steen?
Hi, nice to meet you. My name is Sten. I'm joining you from Sweden.
Awesome. So Steen is a Modular community member, just like many of you. He has a cool demo planned, and I won't say more about it right now. So we'll wait. We'll keep the suspense on. Next, Pramod.
Hey guys, nice to be here again. I'm a product manager at Modular, and I work on the Max platform.
Awesome. And finally, Tatiana.
Hi, I'm Tatiana. I'm an engineer and manager, and I lead Mojo team.
Awesome. We are all here to answer your questions. So this is, as we call it, Modular Community Q&A live stream. So the whole purpose of this live stream is to answer your questions. So if you have questions about any of the products that that you've used, Mojo or Engine, and also some of the announcements that we made, as we share them, as we do the demos, if you have questions about the APIs or how it works and availability and whatnot, we are here to answer those questions. So feel free to put them in the chat, and as we go through it, we'll answer them. So as far as run of show today is concerned, we'll start off by doing a quick recap of the ModCon announcements. We'll talk about the product announcements. We also have a couple of demos that we'll go through. And let's just get started then. So I will start off by pulling up the okay. I assume my screen is visible. Okay. All right. So if you head over to modular.com/blog, we did a blog post that summarizes all the key announcements from ModCon. Primarily, there were 4 key announcements. We announced Max, Modular Accelerated Execution Platform. It's a suite of products for your AI infrastructure, everything from hardware all the way up to deployment, model deployments. And we'll spend a little more time on this. Pramod will share a little more about the different components of Max. We also announced Mojo version 0.6. Yay, the next version of Mojo. In the past, we've done dedicated live streams on Mojo release, but we had so much to talk about in this live stream. So we'll also talk about Mojo 0.6, which introduces traits. We have a demo for traits. We'll talk about those, and also features like GPU support, which are not available today. It's in preview. But these are all the announcements we did. We also had partnership announcements with AWS. We announced Max, and Max will be available on AWS Marketplace early next year. And we also announced partnership with NVIDIA to add GPU support. So those were the key announcements. Now, I'll hand off to Pramod to quickly talk about what is Max. It's a brand new thing for many of you. So let me go ahead and share Max. So Pramod, do you want to just do a quick overview?
Yeah, happy to. So last Monday at ModCon, we announced a new platform from Modular. We call it Max, or Modular Accelerated Execution. So this is basically composed of 3 components, and I'll go to the next slide here. So it's basically includes what we announced as the Max engine, which is a high performance inference library that can pretty much run any framework model. And also it provides hardware portability and generality, so you can run on CPUs, GPUs, any types of accelerators today with order of magnitude speedups compared to frameworks like TensorFlow and PyTorch. The other component of Max is called Max Serving, and what we did there was we also announced a serving library that takes Max engine. And you can deploy it into a production orchestration framework like Kubernetes. It integrates well with serving solutions like Triton and TF serving, Torch serve. And the third component of Max is, of course, as you guys are all familiar with, is the Mojo programming language. It combines usability of Python with really high performance, and it unlocks all the capabilities that the hardware provides, things like vectorization, parallelization. So provides a lot of extensibility. And the nice thing about the Max platform is when you combine the power of Mojo and the Max engine, you can extend the Max engine with custom operations. You can also write all the pre-processing steps of your AI/ML pipeline in Mojo itself, and you can it looks like a big computation graph to our graph compiler, so it ends up optimizing the entire pipeline as well. So this is all it's pretty exciting. I would also encourage you to go to the to our product pages to learn more. So if I go to modular.com Max, this is the starting point of you'll probably learn more about the Max platform, the Max engine, and there's also different pages for serving. We also have a performance dashboard where you can take a look at some of the performance that we publish on different models. We support. I want to say that the Max engine is very scalable, so it supports models, all your classic models from object detection all the way to generative AI models as well. So it runs Llama, it runs all of the new generative AI models as well. So it's a very scalable platform, and we're pretty excited to be pretty excited about the launch. And then this will be available for all of you to try out in early Q1 of next year. So we're super excited about the platform. So back to you, Shashank.
Awesome. Thanks, Pramod. And we're happy to answer questions about Max during this live stream. So the only thing I'll add is that the blog post that we did has more information on sort of the subcomponents of Max. Pramod did talk about engine, Mojo, and Max serving. To me, what stands out or what's exciting about Max is that if you look at traditional AI stacks, you have multiple components. You have C, C++ libraries at the bottom. You have Python programming language on top, and different other technologies when it comes to inference and serving. With Max, you sort of get this holistic single tool chain. If you want to write a pre-processing step, you do that in Mojo. If you want to add a custom op, you do that in Mojo, right? And then you stick to a single tool set that sort of works. So I think that's pretty cool. The blog post goes into some of the other features that we announced. Particularly, I'll scroll down to the section where we talk about the features that we announced. We spoke about Max engine extensibility with Mojo, engine graph API. We have a demo for that. We'll talk about that soon, and also GPU support. So we'll do a follow-up live stream where we talk about GPU support in more detail. In today's live stream, we'll talk about the graph API. It lets you build neural network graphs. So feel free to put in your question. There's one question in the chat. Does Max use CUDA, or does it talk directly to the NVIDIA driver? Pramod, do you want to?
Yeah,
take a stab at that?
I can take that. So CUDA is the programming model and system for programming NVIDIA GPUs. So the way Max works with GPUs is that we actually take Mojo and then we actually produce PTX, which is NVIDIA's intermediate representation for before code gets actually compiled down to the binary to run on the GPUs. So basically, what we're doing in Mojo is we've built all the GPU stack from ground up. Basically, our compiler compiles down to PTX, and then it hands off it to the driver, which then with the NVIDIA driver, which then jits it to the binary. So we're using CUDA in that perspective, and then of course we use we're using all the elements from the CUDA programming model in terms of launching threads, blocks, and so on and so forth, right? So we're using all of those elements, but we're really producing PTX, which gets jitted down to the binary to run on the GPU.
Yeah, I often when I hear CUDA, I think it means so many things to so many people, right? To some people, it means a programming language, but then there's the driver and all the tooling that goes around with CUDA, and I often it's sort of a point of confusion for
Yeah, that's correct.
folks.
It means different things to different people. So I view it as the platform to run software on the GPU, and then some people think that it represents CUDA C++, but CUDA is just more than just referring to the language.
So we use some parts of the CUDA platform and
Correct.
not the others, right?
Correct. Yeah.
So for while we are here, I just want to share that we recently made on our channel a playlist which includes the ModCon keynote announcements. So if you go to the keynote talks playlist, so on the right you see here's a list of talks that were part of the keynote, and there's the GPU section, but also there's the engine, and so this is the Graph API, the Max GPU section. So if you head out to the GPU section of the keynote, there's some demo on the GPU support, but also using NVIDIA tooling like Nsight and all that. So feel free to check that out after the live stream. Just wanted to mention that. So I guess that was a quick overview of Max, and please feel free to put your questions in. There's another question on the similar topic. Do you also target Cudian and BLAS, etc.? So based on what Pramod said, we don't use the libraries that NVIDIA provides. We directly generate PTX. Pramod, do you want to add more color to that?
Yeah. So I guess the question is like, do we, when the inference engine runs on the GPU, do we use any of the accelerated libraries from NVIDIA? The answer is no today. So we have written some pretty high performance kernels, all written in Mojo. That's what Tatiana's team does. So we express a lot of the high performance kernels like matrix multiplication, even things like flash attention, which is used in some of the new transformer models. So we write all of these kernels in Mojo, and then it goes through a compiler stack, which ends up producing NVIDIA PTX intermediate representation before it gets compiled down to the binary. So we don't leverage the NVIDIA libraries today.
Yeah, to add more details to that, we write kernels in Mojo. It goes through our internal compiler stack. We output LLVM IR, and then we leverage LLVM compiler toolchain to generate PTX.
That's pretty cool. Yeah, so I also want to mention that the GPU support is not available today. Like if you downloaded Mojo version 0.6, it's not available today. We announced that it'll be available early, but we are accepting sort of preview applications, I suppose. So if you head over to modular.com/max, you'll have an opportunity to express interest. And some customers are already previewing the software. All right. I think this is a good point, good segue to our community. We have a demo on one of the Max capabilities, but we also have we also run a Mojo competition at ModCon, and it's a good segue to introduce Steen, who's our community member, and talk about his project. But before that, we'll give a quick overview of the competition. So Jack, do you want to take it away and talk about what the competition was and some of the awesome project submissions from you all and the winning submission?
Yeah, sure. So yeah, we put out this alert that we were having a ModCon contest on the 21st of November, and just a few weeks later, we got tons of projects. So I could only choose 6 for the competition, where we displayed all the different projects at ModCon, but we also had a lot more submissions. So in this newsletters, in issue 11 is where I listed all the different projects that we got. And then we got these 6. So the first one is this re-implementation of micrograd, which was really cool. And then we had specials. So this was like mathematical functions that are useful in AI, and flex buffers, which is like a data serialization format. And we also had this project that he made specifically for the competition, just calculating spatial envelopes, which was really cool. And Inferno. So this was like another project like Dynamo, which was the winner of the competition. Sorry, how do you pronounce it? Dynamo. Dynamo is the name of the project. And yeah, this one was really cool. We decided at the end of the competition that this would be the winner, and we got Stein with us today, so he's going to just go through his project.
Hey Stein, welcome.
Hey, nice to meet you. So my name is Stein. I'm a machine learning engineer. And so I get really excited to hear about all the capabilities of Mojo. And in my nightly hours, I have taken it on me to do some home project. So maybe I should share my screen.
Stein, before you start, quick question. How did you discover Mojo?
Oh, yeah. I discovered Mojo actually while listening to a podcast. I was on the train. I listened to a podcast. I got really excited about all the things that were promised at the time. That was 6 months ago almost. Mojo wasn't even out yet. So I've been following it like ever since, and look where I am now.
Awesome.
Was that the Lex Friedman podcast?
Yes, exactly. That was it.
Yeah.
Okay.
That's a good one.
Your screen is not showing up. Could you try sharing it again?
Yes. All right.
So yeah, now we see it.
All right. This is Dynamo. This is a GitHub project I've been working on for already 2 months now. I can see it at the commits. So what is Dynamo? Dynamo is the beginning of a machine learning framework, and I want to implement training capabilities in Mojo for neural networks from scratch. So it's very, very much a work in progress. As you will see down here, I have a list of all the features I still need to implement. But so far, I have a regression example working, and that is what I want to show you today. So let's go to the code. If you go to the project itself, if you clone it under examples, you have this housing.mojo file. And this is a basic example of how you would train a regression example. So it's very much based on the PyTorch API. So you would find, if you're used to PyTorch, you will see a lot of similarities. As a matter of fact, it even includes this housing.py at the same time. So you could really compare it one-to-one, the Mojo implementation versus the PyTorch implementation. So, but let's focus on the Mojo one now. So what do you do? So far, it implements one linear layer. So you create your linear regression model, you define a forward pass, and then what you can do already is implement this data set, which is the Boston housing data set. It's also put in the GitHub as well. So so the first thing you do is you define your training parameters, batch size, number of epochs, learning rates, the usual ones if you're starting with machine learning. So Mojo or Dynamo implements a data loader, which allows you to iterate over the entire data set in terms of batches. And then the next thing what you can do is define your model. You define your loss function. So for one loss function, the mean squared error loss is used for this regression example. And then we have the Adam optimizer that is also included in the project already. So the next step is to loop over the number of epochs and really start the training session. So what we do is we go for a number of epochs, we loop over the entire data set in batches. And then you have the forward pass followed by the backward pass. So what you can do is model it forward. When doing model it forward and the loss function, the whole graph gets graded in the back end. And then on the backward step, the gradients of the graph are calculated, and then the optimizer actually changes the weights and the biases of the trainable parameters of the neural network. So I want to demo this to you as well. So you can find how to do this in the Getting Started guide here. So you have this line that runs that example. So you can see looping over the epochs, the average loss going down, and the project running. Cool. So you have a lot of there are actually a lot of features that I still want to implement and need to implement. I think so far I've been pretty busy with implementing traits. Traits has been out in Mojo 0.6. So I spent some time on improving the backend of how it looks like. But next is the convolutional example. I have one here where I'm trying to implement the MNIST dataset. And I can already give you a sneak peek. When you do MNIST, the MNIST dataset is already loaded, but nothing is happening yet. So that's coming. Cool. Okay,
that's
so
awesome.
yeah, that was it. If you have any questions, please.
You said it's similar to PyTorch, and now I see you have a very similar API, right? If you use PyTorch, you could just pretty much use. The important question is: Are you inviting community contributions yet?
Oh, absolutely. So yeah, my main thing now was like get the base plate down. I spent a lot of time on rewriting it in a good way. But I think now that the graph is there, now that AutoGrad is here, I think I'm definitely open to receive your contribution as well. Yeah, you have you have just a list of all the things I still need to do, and it is a lot. So I would gladly accept some contribution. Just file a merge request.
So building a project like this from scratch is, quite a task. I have a question for you. What was, I guess, the biggest hurdle you faced while you were implementing this? Maybe it was learning the language thing, or what was the biggest sort of roadblock that you had to overcome?
So actually learning a language was quite fast. If you know C++, if you know Python, I think you just know Mojo. And it is quite a daunting task, but if you think about it, it's also Mojo, and that really allows you to take on such a project like this. Because I mean, Python, the speed of Python just wouldn't cut it. C++ is way too complex to even start thinking about taking such a project on. So in that sense, it's Mojo that allows you to do it. And yeah, for me, it was the absence of traits and lifetimes as well that made it quite hard to implement this stuff. But yeah, Mojo is a new language, so there are also definitely things to still look forward to.
That's awesome. Now that we have traits, and we'll do a demo, folks, later. I think Jack has a nice demo for you. Steen, I guess one more question from me. If you have to name one thing that's missing that you would like, what would that be to help make your project more awesome than it is?
Good question. I think
you can also say it's perfect.
Well, no. So I think what I was struggling with last time is still lifetimes. So actually the things, for example, if you put your own struct into a dynamic vector, and when you get it out, it actually returns a copy instead of a reference. So you're still dealing with copies and stuff, which slows down things, makes things more complex. But that actually makes me having to implement a workaround because of the fact that the copy is made. So yeah, I'm just waiting for lifetimes to rebuild the whole project again.
Awesome. You have the right people on today's stream to take that feedback, Tatiana. Awesome. All right.
I hope you like it, and please check it out.
Yeah. Thank you.
Thanks, Steen. Again, for folks on stream, if you have questions about the demo you just saw or questions for Steen, feel free to put those, and we can answer those live, I suppose. I don't see any more new questions other than there's a question on request for lifetime, and I think we've said this in previous streams too. Sort of, it's being worked on and it's coming. So we're making progress. We had same questions about traits, and now that's there. There are a couple of questions, I guess, that came over Max. There's another one today, which is, will Mojo Max support Apple Silicon GPU? It's sort of a forward-looking thing. Anyone wants to take that? Promote Tatiana.
I mean, I can take that. So we're focused on. I just from a customer perspective, we're focused on NVIDIA GPUs today. But there's the technology that we've built is scalable for other types of GPUs and other types of accelerators, which we'll be adding to our roadmap. Right. So there's no reason to preclude other types of GPUs, but it's just a matter of prioritization for us.
Makes sense. And there's another question that came a little earlier. It's Max related. Is Max engine written entirely in Mojo?
So the way to think about it is that all of the high performance kernels within the Max engine, like that's where we leverage the power of Mojo, right? And that's where we get performance from. So that's the right way to think about it. And we express all of the high performance operations like matrix multiplication. We have kernels for flash attention or element wise. So all of those high performance kernels are written in Mojo, and that's where that's where the engine gets its power and performance.
And that's actually probably a good segue to the extensibility of Max with Mojo, right? Like you said all the high performance kernels are written in Mojo. Right. One of the things we announced at ModCon 2 was the Max engine graph API to be able to articulate graphs directly in Mojo, and we spoke about the benefits of using Max, writing pre-processing, post-processing stuff in Mojo, but also custom ops and defining your graph in Mojo. So with that, we actually have a demo planned for you today on this brand new stuff, which is not yet available to you. Will become available early next year, but we have a working demo, so we want to show it. So with that, I'll hand off to you, Dan. You want to introduce what is the engine graph API and how does it work?
Thank you. Yes, happy to. So let me quickly share screen. So we've been talking about the engine a lot and how high performance with high level expressibility. So basically, you have a graph of ops, and it's executed super fast with optimized kernels and powerful compiler optimizations. And as the previous question mentioned, the kernels themselves are written in Mojo. The graphs that it currently runs are not. They're written in TensorFlow, they're written in Onyx, they're written in PyTorch, and we import them into the engine and run them fast. With the graph APIs, we want to enable Mojo developers to build such graphs directly from Mojo. And today I want to do a quick show and tell about what this API will look like. A lot of things are still in motion. They are subject to change, and we hope to release it as soon as possible. But I can go through the very basic concepts and show a little bit about how the API will look like.
Dan, before you start off, I think some context setting for some folks who joined recently or have been following Modular recently. So we've in the past announced Engine and Mojo, right? Mojo is available. You can download it. You can use it today. Engine, on the other hand, formerly called AI Engine, was in preview. So some of you who requested for preview access have access to Engine, have used it. And the engine, the way it worked was, you bring in your model from a popular framework, as Dan mentioned, and you import it, and it would, it's an engine that it's a compiler and runtime, it will run it fast. So this stuff is an extension capability to the engine product, right? And now it lets you author graphs versus just import it from a popular framework. Did I set that up right from historical context? Okay.
Exactly.
Okay.
Exactly so. It lets you author graphs. Basically, what that gives you is it lets you program the engine. Whatever the engine can run, you can now send it instructions, send it operations from Mojo. And it's super exciting to see what the community might enable with this. Perhaps even we saw Steen's demo earlier. It would be super nice if we could integrate the two, for instance. And the possibilities are quite limitless, I would say.
More work for you, Steen, next year.
Or hopefully less, because we offer
less work. Yeah. True.
All right, so let's dive in a little bit. Let's have a quick look at the basic concepts in this Graph API. The concepts ought to be familiar with everyone who's been doing graph programming. So we have this module, which is basically a container. It contains things. Among the things it contains, a graph. What is a graph? A graph, well, is just a callable within the engine parlance. It has a name. It has a bunch of input types. So in this case, our graph will take a scalar of int32 type. It's a single scalar tensor. The return type is similar, a single int32 scalar tensor output. And then we have a special op. Basically, before I go to that, once you have this graph, you just add ops to it to construct it. And one of the simplest forms of graph is a graph that does nothing. It just returns the input. So it's kind of an identity function. And this you do by adding a special output op to that graph. It takes the graph argument, this input that we've set up here. You just return that directly. And this is basically how you build a very, very, very simple graph. Again, low-level basic APIs. You create graphs and you add ops to that graph, and you tie them together by wiring their inputs and outputs. And once you have that graph, you can obviously verify it. Here, this is an actual unit test that I picked from our code base. You can print that graph, and then you can see an internal representation of what it looks like. If you're familiar, again, with, for instance, Onyx graphs, this might seem familiar. We have this graph IR here. It has the name. It has the output op, and otherwise it's empty. So again, low-level, simple API, very foundational, very basic, very primitive. And that is by design so, because we want this API to be built on top of. We intentionally don't offer high-level primitives like neural network layers and TorchNN or Keras-style APIs, because we hope that would be a separate API that can be built on top of. All right, so with these basics, let's see another example of an op. This one, the add op that we can add to the graph. Obviously, as its name implies, it adds two numbers. So this graph has two inputs, two scalar tensors as inputs, and the add op just adds them together, and then the result is stored in this y variable, which is then over to the output op. It gives us a graph that adds two numbers. And this is the essence, the core of the Max Graph APIs. Extremely, extremely simple. Now, of course, you might notice when you're building ops, you have to do some boilerplate, some tedious boilerplate things. Like, for instance, you're adding two int32 scalar tensors. But when you create the op, you also have to specify the output type, which is kind of redundant. It gives you power, though, because it lets you control exactly what ends up in the graph. So it gives you power. At the same time, it is a bit boilerplatey. So to help out with that, we added a few helpers. For instance, this operation here, you can express it more simply with that y equals g of 0 plus g of 1. So you can use the plus operator to just add two tensors together and that lets you write code a lot more complex, more compact. At the same time, we have additional helpers like argmax, and we have a lot more reshapes, what have you, and we're going to add more and more. And so this is in a nutshell the graph APIs. I will say it again, simple and basic, and yet it's still powerful enough to let us write more high-level things, like, for instance, a llama model that we implemented using this API. And here it is, an example of it. I'm going to scroll slowly through it. As you can see, we have here, we made up a few structs. Now, these are not part of the Graph API. These are just helpers. And you will probably notice they're kind of similar to Steen's structures. They are high-level neural network abstractions. These are just helpers that we wrote to help us in building the model. But what we wanted to test is the Graph APIs, the usage of Graph APIs to build such models. So here we see we are adding constants to the graph. We are adding reshape ops. We have this rope function, which is described here, which adds more ops. Splits, operations, of course, multiplies, arithmetic operations, tensor concatenations, and so on and so forth. So this is this was, for instance, the attention layer inside the Llama 2 model. We have a few more, a feed-forward layer, an RMS norm implementation. This is a very nice example to show how compact the graph code can be. This is the entire implementation of RMS norm as a layer, simple and basic. And then we have transformer blocks. We put them all together. We build a transformer, as you would expect, and go even further. We built our Llama 2 model. Now, the model itself, it loads pre-trained weights from a file, so it can run an existing trained model, and it all runs nicely. And that's it. This is our Llama model. A few words about how to run it. I'm not going to go into too many details, but we have our Llama struct. We pass this once we have this this model, then we build it, and that gives us that module that contains our graph. And then we can take that graph, hand it over straight to the engine API to compile it and to execute it, which are part of the Max Engine APIs that will also be released soon. And that's it. That's Llama 2 implemented with Max Graph APIs. I hope you would agree that it looks the implementation looks reasonably readable, I would say, despite the fact that it uses an extremely low-level API. It's still able to leverage high-level graphic concepts like NumPy-like concepts in the API. All right, so this was the walkthrough of the Llama code that I wanted to show. One last thing I want to add is we have this API, which is super nice. It lets you build graphs in Mojo. It will also come with a helper that will let you import graphs from an existing framework like Onyx or PyTorch or what have you. It will import the graph by generating the graph code for that. And here we have an example for MNIST. All this file was automatically generated from an Onyx file. So you see lots of ops all generated into code. What does this give us? It gives us the capability to do graph surgery. Like for instance, now I have this generated code. Well, suppose I want to insert an op, insert a custom op somewhere. Well, I just do this, right? Let my result is g.op. We give it my fancy new op, and then we give it input types, and then we take the results and we wire them into the graph. Suppose we want to replace this tensor. Why not? There you have it, graph surgery in a nutshell. Again, low level, intentionally so to give you full power, full programmability, and full control, and especially to build on top of, which is why we're very, very excited about the upcoming release. We're excited to see what the community can build on top of it and how it can be integrated, for instance, in existing frameworks. And with that,
awesome. And
thank you.
what are we saying about community access? As in, when will you said people will have access to this? What are we saying in terms of?
So we have a little bit of polishing to do to put it in. We're obviously we are a bit perfectionists, and we like to bike shed every name and every detail to make sure it's just right. But we hope to release it early next year and make it available.
Awesome. That was pretty cool. I didn't know. I mean, full disclosure, I haven't used this, right? But I didn't know that we could generate these graphs from existing models. That's pretty cool. I can think of generating these graphs and adding pre-processing ops into them, and post-processing stuff if you want to, and then it'll be just one large graph. And if I understood correctly, when you call the engine, it optimizes the whole graph, which includes these extra ops, right? Not
Yes.
just the model. So that's, I guess you can get some extra performance because it's able to see the whole pre-processing and whatever custom stuff we add in.
Yes, exactly so. And I believe there is this is probably the subject of an upcoming discussion. But what the engine offers us, it offers the user the capability to write new ops, new custom ops in Mojo for the engine, and the engine still retains the capability to nicely optimize those together with the existing ops. And I believe Tatiana can say a lot more about this.
One question before we take some from the stream. The ops the operations that you use in each of these op, is there a fundamental list of things that we have to pick from? Like there was add, and there's a fundamental list of I guess core operations that we have to compose these bigger ops from. Is that
Yes, that's
the
a
right way
great
to think
question.
about?
Yes, that's a great question. The engine comes with a set of core ops that you can use from. Obviously, there are the usual suspects: constant, slice, matmul, of course, transpose, the usual thing. And we will be maintaining a list of documented ops together with their semantics.
So what will authoring like a custom op in Mojo look like then? That would be not composed of these core ops, but still can be part of the graph?
Exactly, yes. So a custom operation, that would probably be a great topic for a future episode. But that there is a separate special API. You write a function in Mojo, and you write it with low-level, high-performance code, so you can go crazy with implementation. You don't use these the graph ops. You write pure low-level Mojo code, and then you give it a special annotation, and that makes it available as a custom op within the engine.
Awesome, and that's going to be part of the graph optimization, fusions, and all that.
Exactly.
That's pretty cool. There's one question here, and this is there AutoGrad implementation in Max? I assume the Max engine for backward passes of these graphs, or is it targeting forward pass only? So I guess my quick answer is currently this is a forward pass inference only solution. Is that right?
That's right. That's right, Shashank. We don't have AutoGrad yet in the in the Max engine or otherwise. But
Awesome.
I do expect that the graph APIs, when we will have AutoGrad, the graph APIs will combine neatly with the AutoGrad capabilities.
Awesome. Thanks, Dan. So that was a cool demo using graph APIs. This is pretty cool, especially the importing and generating the graphs part. I think we are understating the value of this whole graph optimization thing, because you can't do this with other solutions that exist today, right? Like your model is one graph, and whatever steps you do or add is like its own thing, and you never look at. No execution engine looks at the whole thing and optimizes it. So this is sort of special, I think. Pretty cool. Thanks, Dan. So we have another demo, and I think this is a nice segue to the other announcements we had. So we spoke about Max and Max demo, but we also released Mojo version 0.6 at ModCon last week. So I will hand it off to Jack to talk about the biggest feature in Mojo version 0.6, which is traits, but also maybe touch upon we'll follow up and touch upon a couple of other announcements, because we only have time to cover one thing now. Jack.
One sec. Yeah, so we had a lot of features released for 0.6. So if you go to the changelog here, Mojo/changelog, you'll see that there's quite a lot of stuff that we released. But the big feature was traits. So up the top here, you got a lot of information. It tells you about it in this changelog, and then in the Mojo manual, this will continuously get updated. But it tells you all about traits and gives you some examples about how to use them. So it's quite a big documentation section. And then also in the changelog here, there's a blog post, a link to it. So this goes over like a lot of examples about how to use traits, and kind of builds upon a simple one and then adds features to it as the blog post goes. And then when you get down to the bottom, I think I got it up here, there's the database traits section. So this example is just showing you how to build like a interface to a database, and then doing two different implementations on it. So the first implementation is using SQLite, and it just shows you how to actually create the database with SQLite, and then insert some values into it and print them. And then you can see it actually, like this code actually works if you want to run it. And then it has a Mongo version as well. So you have the same interface where you can insert values and then print them all. And then you can run it through Mongo as well. So yeah, it just gives you a bunch of examples. If you don't understand what traits are, then after you read this blog post, the aim is that it'll help you understand how everything works.
Yeah, I should mention that this is a really cool blog post. I recommend all of you read it. All the code stuff is already available in the Mojo GitHub repository. That must be linked in the blog post. Jack, for sort of the uninitiated, I guess, what is a very high level, like one sentence summary of what a traits is? Because I guess a lot of us, like Python programmers, like don't think about language features like that, right? So what does this enable for a language developer?
Yeah, so it's all about generics. So if you think about Python, you can run any object, you can run through any function, and you get a runtime error if something's wrong with it. So if it doesn't implement the methods that you run in that function, then you'll just get a runtime error. And traits enable you to write generic functions, but then it's a compiled language, so you still get all the speed benefits, and you get compile time errors if anything's wrong. So instead of getting a runtime error when you put your code into production, it tells you what's wrong at compile time. So one way to think about traits is they're just generics. It's a way of doing generic code.
which is what you had in your example where you mentioned you had the exact same interface, which is like you'll have insert operations and whatnot in all databases, but
Yeah.
you don't have to re-implement them. You have a common trait for all of them, right?
Yeah. So this database example, like a lot of languages, when they're introducing their generic features, they'll use this example. But it's also for simple things as well. So say if you wanted to sort a dynamic vector, you can use traits to do that, and then write different implementations for the sort. So yeah, that's what it's all about. It's just writing generic code, so you don't have to keep rewriting the same thing for all your different types.
Awesome. There's a question here, I think not necessarily about traits, which is, will Mojo get Python style union or will it get Rust style enums? Is that something we support, or I don't know, have you said something about support? Oh, sorry, Tatiana, you muted. Yeah, go ahead.
Okay. This is forward-looking. I think the short answer, we haven't decided yet. So if you have thoughts, feel free to start community discussion. There is another question there about LED. Yes, LED is going to disappear. We love LED, but we found that it actually doesn't bring us performance benefits, and it will be much simpler if you can just use var.
Okay. The question was, will LED be discarded from the syntax, right?
Yeah, it will be.
Oh, yeah, that's nice. That's news to me too. That's pretty cool. Yeah, awesome.
Yeah, if you go to the GitHub repo as well, the public repo, there's a proposal there that Chris wrote up, and it goes into some details about why we're getting rid of let, and yeah, you can contribute to that discussion.
In the discussions, Jack?
Yeah, in the proposals folder there where you are.
Okay, I need to go figure that out now. Okay, did you have a couple of other things to cover with traits, or should we discuss some of the other features in the release?
No, that was it. Yeah. So, did you want me to bring up some other things that we released?
Yeah, I think a couple of other big, big items was we open sourced Mojo documentation, right? So let me pull up the screen and we'll walk through it. So you could find documentation on Mojo. Let me open up the documentation, right? So what we did with this release was the documentation is now available on modularml/Mojo. So under the docs directory. So all of the documentation is here for you to see and also contribute, or complain about it, file an issue, pull request, and whatnot. So this is a big one, I think, on our path to open sourcing components of Mojo and Max. I think that's another big announcement that we had last week at ModCon. Was there anything else that you wanted to cover in the language specific side of things, Jack?
Yeah, if you just go back one to and then go into proposals.
Yeah.
And remove let, the second from the bottom.
There it is. Okay.
Yeah.
Okay, I guess this is another page to bookmark, right? Lifetimes and dynamism, remove let. Okay, this is pretty cool.
Yeah. So this is like what we actually do internally. So there'll be a proposal, and then people will go over it and add comments if they disagree with anything, so we can come to a consensus. So at the moment, we're talking about like the future of traits and what we're going to do with traits going forward. And I think they've started to come to a consensus on that. So if you check back here, like we'll add proposals here when we want the community to discuss it and leave their comments. So if you have any feedback, read this document and leave it there, and we'll all read it.
Awesome. A couple of questions in the chat. I think there's one. What kind of functions won't be able to be called at compile time? The ones that do syscalls? Does anyone want to take that? Is it clear?
Yeah. So there's things like, if you're printing, you can't run that at compile time, but basically everything can be run at compile time, can be compiled. So when you do the alias, like alias x equals, and then run a function that runs like at compile time before runtime. And that's one of the really cool features of the language. Like any function can be used at compile time or runtime. So the majority of things will work. You'll just get some errors when you're trying to do things like print to the screen.
Awesome. I guess the couple of other small UX related things we announced last week with Mojo version 0.6 is the documentation based on some feedback has been simplified, especially the Mojo programming language manual, which used to be this one large manual, has been broken up into different parts, so it's just easier to digest and easier to navigate and learn. So that was another, and most of these, as I mentioned, are part of the changelog that Jack went through too. So feel free to check this out, and also the blog post that Jack had on traits. Okay, so there's one other question we'll take before I guess we start to wrap up. This one is, do you think Mojo syntax will naturally diverge from Python syntax quite heavily as the language matures? It must be hugely challenging to retain similarity.
We are doing our best to stick to Python syntax. Obviously, when we support things which go beyond Python, we have to improvise, but we'll see.
Thanks, Tatiana. All right, I think we got through most of the questions that came in. I think there's a question for Steen. How fast is Dynamo compared to PyTorch? Have you have you compared it, and also what I guess opportunities are there to further improve the project and all that? Any thoughts there?
Yeah, I want to make clear I haven't actually benchmarked it against each other. The main reason for it is because I'm just implementing a new feature as well, while also having the ability to improve performance. But yeah, like diving into getting every piece of performance out is the next step and work in progress.
Awesome. I think there's a follow-up question on the open sourcing thing. At ModCon we did announce that we'll open source components as we move through next year and so on. I think Chris also announced on stage that we'll have nightly builds. So question is, any news on the nightly builds of Mojo? Is that made any other announcements?
Yeah, I can answer that. Nightly builds are coming. Please be patient. Sometime in Q1 of 2024, we are going to put out nightly builds. And this is very important because we want everybody in the community to be able to contribute to Mojo. And to do that, you need to have the latest version of the code. And that's what nightly builds will give you. Now, actually putting out nightly builds is a little bit more complicated than just saying that we want to do it. There is a lot of implementation work involved into making this happen. So sometime soon it's going to be there.
Awesome. Thanks, Tatiana. Couple more, I think we can do one or two more questions before we fully wrap up. How much Mojo data frame operations faster than ordinary Python pandas? I think we don't have data frames in Mojo today. There might be community projects out there that do similar things, but yeah, and if there isn't one and you're interested, you should totally go out and build it and share with us, and we'll feature you in our upcoming newsletter, Jack. Awesome. I think this is a good place to wrap up. To quickly sort of recap the recap live stream. I think we spoke about sort of the announcements we did. The call to action, of course, is like go check out the launch blog that we did, which has all the key announcements. Some of them are available today, like Mojo version 0.6. Some of them are announcements for early next year. So feel free to go check them out. And all the Mojo stuff is available. There's also other blog posts that Jack's blog post on the traits is another thing that you should all check out if this stuff interests you. And if you're interested in some of the partnership stuff that's also here. Graph API, that was a pretty cool demo. Thanks, Dan. And that's, again, Q1, keep on the lookout. I would say one of the best things to do is subscribe to the newsletters that Jack puts out like pretty much every week. It's the best place to see community news, but also some of the content stuff we put out there and new releases. So feel free to go sign up here, and of course keep watching live streams for Q&A and bring your questions. This is really not a news sharing live stream, but a Q&A live stream. So the more questions you can bring, we have folks from the company answer. Okay, with that, I think it's a good time to close. So thank you all for attending. Thanks for giving us your precious time and listening to us and asking your questions. I think your feedback and questions make our products better. With that, any final words from any of our folks on the stream here? No? Any final requests from the audience? No? Okay, awesome. I think that's our goodbye then. See you in the next live stream. Bye, everyone.
Yeah. Happy holidays, guys. Bye.
Yeah, happy holidays.
Thank you. Bye.
Bye.